shouldn't, and things like that. First of all, given that we're a small group, who are you is a user of WildFly, or knows it at least? Okay, good. And no, you don't know it? Others don't know it at all? Anyone heard about JBoss application server before? Well, WildFly is the renamed version of the JBoss AS. We rename it to avoid the confusion among the community, which is the WildFly now, and JBoss EAP, which is the commercial offering by Red Hat. So it's in the wild, it's a community-driven project, and everything is happening in open source. Okay, so let's start. Why would you even want to customize the server, which is already quite small and well optimized and runs quite fast? Well, you can remove the stuff you don't need. You have a deployment that only uses, let's say, servlets, web, and some JPA. Why would you run and include web services, so JAX-RS or some batch support? If you don't need it, remove it. It gives you a faster deployment, lower memory footprint, and this distribution itself is smaller. So what's better, to copy 30 megabytes of application server or 150 megabytes? I think the smaller is always better, especially if you don't need all the stuff that the big thing provides. If you look at it, quite simple, the modules, this is where we keep all, for the guys who don't know the WildFly itself, it uses modular class loader. The modules is a folder where the whole structure of the modules with the jars and everything is located. And this pretty much represents most of the deployment, the whole distribution size, about 80%. Then there are client libraries like for connecting remotely for AGBs or CLI and so on, which is around 10%. And documentation actually adds up quite a lot. In this doc stuff, we mostly include the schemas for all the configuration options, for the XML files, and so on and so on. And then there is a configuration, which are like two files, standalone XML and domain XML for the guys that know the server. And then there are some resources like scripts to start it, stop the server, and so on, which is the smallest part possible. I want to talk about what subsystems actually do and why you might need it or not. These are not all the subsystems the server provides, just basically the ones that maybe someone actually cares about. The order is not important here at all. I just threw it in together from some file I had somewhere. So manual, it's not JPI, it's the first and last. So. Okay, for some people, of course. The JPI subsystem provides the JPA integration, so if you have Hibernate in, and basically if you have your application that has persistence XML, the JPA subsystem is the one that says, this deployment has the maintained persistence XML file, that means this is the JPA deployment. I should install the entity manager, we provide all the stuff for injection, and anything that has to do then with JPA itself, Hibernate in general. And then you have the JSF, JavaScript faces, that also takes a look if you have the faces context, XML file, and things like that in your application, and some tag lips as well that can trigger it and so on. Basically, if you would remove the subsystem, that wouldn't get activated automatically. You can still manually configure JavaScript faces, like this, add the servlet and all other stuff. But why do it if the server can provide it for you? But it could be useful, for example, the JSF subsystem provides one version of JSF, which is one of the server. If you want, for example, do some more customization, use a custom version of JSF and so on, you can just drop it into your deployment as a jar and disable the JSF subsystem, and you can do whatever you want with it. It's a really common thing that people want to mess with. Then you have the logging subsystem, and you can actually remove pretty much every subsystem you see here, but don't remove this one. The server won't even boot anymore. This is like the first and the only thing we actually really need. It provides the logging configuration and logging support for all kinds of different frameworks, so you can actually centrally manage what to log and where to log and so on. And even if you use JBoss logging KPI for logging, or simple logging for set4j, or log4j, or log4j2, and there are some others, it will still end up in a central management and central place how to manage. You can also disable it, and configuration for that is here. Then you have a Tomaž Cerar subsystem, which is the REST-easy integration, if anyone does the REST stuff and so on. The messaging subsystem is quite big, and the name is really misleading these days, because we renamed the messaging 3 times. The implementation package is completely different. But in general, it provides the JMS. And if your application doesn't use any JMS stuff, why have it in? Remove it. Same goes for web services. Transaction you usually use, so keep that in for your sake. Things can get wrong if you remove transactions. The web services is a really interesting beast. How many of you use web services? How many of you use web services intensively, like via security extensions and all that kind of stuff? Pretty much no one. Would you believe me that I told you the web services subsystem brings in for more than half of all dependencies in the size of the whole application server? Just because of all that obscure security-related and interoperability-related sub-project to web services that needs to be there so we can pass the PCK for the IE7. But in most cases, people don't need that. People say, yeah, I don't use web services, I add annotation at web service and on my stateless bin, and that's about it. And that is like maybe 1% of functionality what this provides. Then there is Wild subsystem. CDI, anyone use it? Well, yeah. It would be funny if you wouldn't, basically. Provides the Cdi Declaration, everything that goes to it. This is the new one, the batch, that provides the Java batch. Probably no one used it before and probably never will, but maybe. It's in part of Java 7. Batch support to actually have standardized way how to write batch applications. Then we have the IO subsystem, which is basically what it says. It handles the threading for all IO related operations. When it comes for web requests or remote link requests or any kind of request that need to process something asynchronously and need some worker thread processes and so on. This is configured by IO subsystem. And the new one in 8 that goes together with IO is Untitled. Anyone used Untitled before? You guys know Tomcat and JavaSwap probably from older versions. In WildFly 8 we replaced JavaSwap with Untitled, which is our own homegrown web server, which allows us to do lots of customizations of the server, like having single port exposed on a firewall and do everything via HTTP upgrade and things like that. And in our stuff that goes together is like request controller for graceful shutdown, so we can actually have a single point to count requests that come in and so on. And it's really, really fast. Currently on the tech-empowered benchmarks, with a year-old version, we are still in the 3rd place and the 1st place for any Java-based web server, so we're kind of fast there. And Untitled itself provides not just static file content and serving, it provides servlet JSF support. Basically everything that you think of when it comes to web, Untitled does it. Even the proxy support we added in now, so we can actually configure one WildFly proxy request to another or load balance them and so on. This is a really cool stuff. It's the biggest change in 8 and 9 that we did. Then we have the finished span JGroups, basically all the clustering stuff. You guys probably know that. But if you don't need to use clustering, why have it? Remove it. It's like 10 megabytes or 12 megabytes of jars there. If you don't use it, just let's worry about it. The network stuff, you probably don't want to remove that unless you're a hardcore Spring shop, so to say. The connector stuff provides data sources, resource adapters, JCA adapters, and so on. Basically, the data sources are what you want to have. And there is one that the manual loves actually. It's the bin validation. I think you wrote it actually.
No, I think I did. I did fix some things.
Yeah, of course. It's basically a really small subsystem to just make sure that if you find the validation XML, right? To enable validation across all the other subsystems that need to work together. Either it is the CDI or HTTP or so on. All the components need to have validation enabled. If you remove that subsystem, validation wouldn't work. For example, you don't actually want to use validation, but some component that you bundle in your deployment has that validation XML in it, and you don't actually want it to start validating everything because of one component. Just remove that, and everything will work normally now. But you won't get the big validation support out of the box. The deployment scanner is a really, really small thing that just makes sure that if you drop your deployment like var jar into deployment folder, it picks it up and deploys it. If you don't have that, you can still deploy via the CLI tooling, the web console, and anything, but just the physical file folder scanning won't work. It's a small thing, you can always keep it in. But it actually has some threads that it needs to work, so if your system is really careful how many threads it can use, remove that, treat that 3 threads less, and so on. And the E subsystem is just basically a meta subsystem to make sure that dependencies on APIs like the JavaX APIs that you need are there, and some default configuration like what is your default data source, what is your default mail session configuration, so on, it's configured there. Most cluster, the clustering stuff that we have that works together with Apache or also with Undertow directly. The naming, GNDI, everyone knows that, everyone needs it usually. Pojo, beyond the manual, you know it? You probably know it. The old one, the MC. No, it is what Alej did and Adrian, the MC2. Basically backward compatibility.
Why do we need it still?
Users had old codes, Java deployments that had that, and still want to use it. Why not? It's a really smooth, like 2 megabytes dependency, and it really works well. And you have remoting that makes sure that you can actually connect remotely to the server, make a configuration there and so on. SAR, mail, security manager, ILP, and request control. Really small things, and it doesn't really matter if you have them or not. The ILP maybe is a bit bigger, which is the core by implementation, which probably no one uses, so you could really remove all that. That's the idea. There are plenty more, but I just wanted to show what the stuff does, and if you remove it, what happens. If you remove, for instance, mail subsystem, you won't have any place where to configure mail sessions, which you could then inject and use. So if you don't use that feature, remove the subsystem. You don't care if it's there or not. If you don't use the service archive deployment, the SAR files, you can remove the SAR subsystem, and so on and so on. Similar with like security manager, we actually have it by default disabled, and if you add it, it enables security manager stuff. So it's quite simple, but from the point of view how to deploy it and how big the whole application service, those are really irrelevant. Web services, well, batch, those ones you actually want to get rid of if you don't need them. One thing I want to show, if you're doing this manually, we'll go a bit more into details what the stuff does and how it works. This is the standard command how to start the application server. It is hidden in that standalone script as your batch script. What it does is say Java jar, Java small jar, tells where the modules folder is, and then these are the commands from it. If here you would just say here, or JBoss as server, without anything else, it will just start the server. That's it. That's what the script does. In this case, we'll just ask JBoss modules to give us a dependency tree of all the modules and dependencies of the module or WildFly extension IO, which is the IO subsystem module. And this will tell you what are the dependencies. It will tell JBoss as server, JBoss API, common beans, and so on, and where it comes from. I'm showing you this because this is the way how you can see what you can remove, what you cannot remove, because some stuff can just break if it doesn't find it here. It's a useful tool. If you use Maven dependency tree, you know why it is useful, and this is pretty much the same, just it works on modules. And now we'll talk how to actually build it. This is the customization if you want to change your one, the server itself, but if you want to build new one, it's a bit more interesting. With WildFly 9, this is the new stuff. Just a second. We split the code base in two parts. One is WildFly core, which contains only the smallest part of the server. Actually, if you boot it, it does nothing. You get the admin console if you extra install it, but you get the CLI, you get the deployment support, you get all the infrastructure the server provides, the management paths, the REST API to manage it and so on. But it does nothing. You can start it, you can manage whatever it has in it, but if you would put a deployment in it, you would just say, deploy it, because there is no subsystem to actually look at it. Oh, this is a JPI, let's deploy JPI, or this is JSF, let's deploy it. Because nothing is there, you just say, okay, I'm fine, I'm done with it. It's pretty much meant just so that everyone, we have lots of teams inside Red Hat and Javas community that want to have the management functionality of the app server and how it's configured and what you can do in the model, class loader and so on. But they don't want all the EE stuff. So they said, okay, give us something that we can just use as a bare bone. And we'll build our own application service on top of it, which won't be EE or anything else. So this is why WildFly core was born. It is a 15 megabyte application server that you can use for whatever you want. It comes with the Undertow web server that doesn't support servers and things like that. Just static file server like rewriting and proxying and things like that. But no servlets, no JSPs, no JSF. You can drop it in your deployment and use it from there on, but it's not there by default. When I say it contains Undertow, it contains Undertow as a library, but not as a subsystem, so you don't have the configuration options and so on. Then the other thing we did, because it was obvious, because there are lots of people that use Tomcat, and then you come to WildFly and say, nothing works as it used to, because they bundle half of the world there, even if the application server already provides all that, and jars start clashing. For instance, they put GSP libraries or functions of TLJS or the older version of app server specification, like server 2.4 jars they have in, because they clash with the 3.1 that server provides, things like that. So we said, let's do something that will just behave as Tomcat would. This is where the WildFly servlet got born. It's basically just WildFly core with Undertow subsystem in this case, with the servlet support, the JSPs, and some JNDI, and that's pretty much it, I think. It's like 4 subsystems and everything. And it's 24 megabytes. The sizes will go down. We are not done yet. And you get Tomcat. You get the management, you get the main node support, you can just manage groups of servers and deploy stuff, and you won't get any problems with clashes with different EE versions. You can just bundle everything and it will work. Then you have what we always call application server, WildFly full, which is, we call it internally, but it's WildFly as we know it. It's the whole bundle, it's around 120, 30 megabytes. It varies because the nightly builds are one day more, one day less, but basically. And it's based on WildFly server and anything else. You can see the pattern here. You know? First one, this one builds on that one, and this one builds on this one. We just add stuff on top of it. And we'll take a look how you can use that. The whole server, if you look at this, is consistent of 3 feature packs. That's how we call it. The first one is called WildFly core feature pack, which is the baseline. And then you have the server feature pack and the full feature pack. And then you can just provision the distribution based on that. With your customization or without it. That's completely up to you. And the feature pack can have all this kind of stuff. It has modules, new jars, dependencies if you want them. The module is also a subsystem, so you can actually add a subsystem, add a configuration for a subsystem, add extra resources, extra scripts, I don't know, not standalone XML, but start me, ASCII file or something like that. It can always extend another feature pack, or 2 or 3, doesn't really matter. And what is really, really important, and this is what we talked with Emmanuel earlier, is we don't have any jars. Those build with feature packs, we don't have any binary jars in there. We always have just the mainland coordinate, which is really important for later on, I'm going to show you. And this feature pack is done as a mainland build. It's basically a plugin and some extra configuration for it, which looks something like this. This is setting from semi-real example of the code. Basically, you say, I want to start with a core feature pack. Here you could just add like 3 of them dependencies, not just one. And then the configuration, I want to use this template for the standalone, and subsystem, that's an XML file, just specifying what XML files, which subsystems you have. And the end result I want is standalone XML, or standalone full XML, or standalone mine application XML, whatever you want or need. Then you can like alter the permissions in file or some line endings and things like that. This is just to make sure it works on all platforms the same. This is from the servlet distribution that we use, and it works quite well. And to build it, this is all you need to add to make it. Basically, a plugin and tell them this is the feature pack that you need to want to build, and that's about it. And when I was talking about model XML, how many of you actually saw the model XML beyond the manual? How many of you heard about modular class loaders? In general, okay. Then let's stop there for a moment. This is a thing that is actually going to happen to Java 9 as a standard, as part of the core Java. We have it like for 4 years now, since Java 7. It's implemented by our project called Java's modules, and the idea is that each module has its own class loader, and you have to explicitly specify what dependencies the module has. And those dependencies are not transitive, which is the most important part, except if you specially say you want to have transitive. But it's always one level transitive. In this way, you can always be sure that the classes and the class loader will see just what you say it will see and nothing more. This is, to be fair, most of the people have a problem when they come from JBoss 4 or 5 to 7 or 8, 9 now. It's like, yeah, get class not found exception. You know, I used to have just one big lib folder with all the jars in it. There is no big lib folder now. Now it's a tree structure. In this case, it would be, because the model name is called org hibernate. It would be in folder modules, and as I said earlier, org hibernate main, because it's the main slot. This is like the versioning of the modules. And it's its main, we don't specify it here. And you would have this model XML file there. And here you say, this module has these resources, the artifacts, hibernate core, hibernate inverse, and hibernate endpoint. These are the main coordinates, basically. And these are if dependencies, so it will work. These are not actually all, just for the presentation, I cleaned it out. So, okay, I need ASM, faster XML, Java X API annotation like that. So, which makes sense. All the stuff that has to do anything with Java EE, ORM, JPA, like validation, persistence, and so on. And we know that Hibernate uses Antler as its grammar building tool, so it has to be there. That means that also the Antler model we have to define in a special module and have there. As a result of all this, that's how the modular system works, and the deployment itself is also a module deployed that only have dependencies based on what we find in deployment. Basically, if you find persistence XML, we add dependencies to JavaX persistence API. That means that your application will have access to classes, the API classes of the persistence API. And so on. So it's really slim. We don't actually guess where the classes are. There is not like 200 megabytes of jars full of classes that you need to scan and see this resource there, is this class there, and so on. We always know if it's here or it's not there. So just fix it, make it work. This is kind of important these days because the Java 8 was the first that promised to have a Java modular system to have something similar to this. Now the Java 9 is actually happening. Now the guys are working, the spec is basically done. They're working on reference implementation for the JDK itself. And it's pretty much based on what JBoss modules is. The guy that wrote JBoss modules is one of the members of the spec team. So it's pretty much there. They improved a few stuff that we couldn't because when you're changing the JDK, you have a few more options you can do. But basically, this is something that's going to happen in Java 9 and everyone will be able to use it. Doesn't really matter where it is. You probably heard about OGI, and this is a similar concept where everything is really scoped. But the problem with OGI is that it's too specific and too fine-grained. You can go there to a level of which package in which jar is imported or exported where. In this case, it's much more liberal. One module can be 10 jars. We don't mind, you know. If you say my module is org Hibernate, as in this case, if this module has everything for Hibernate it needs, that makes sense to me. Why should I care if Hibernate has dependency to Antler or faster XML classmate stuff? I shouldn't. I just want to import Hibernate. Give me Hibernate. Make sure that all the classes, all the jar needed are there. So this is how it was designed and works really, really well. As a result, the average boot time of the AS7 or now WildFly is around a second and a half and 2 seconds because we know where to load classes. It's not like guessing and scanning 200 megabytes of jars and so on. It's a really, really game changer.
Usually it's the libraries that actually provide the modules. So for Hibernate, search, and OGL, we provide a module that you can copy into your WildFly distribution.
Yes.
To say, then again, it's like if you have some kind of framework that you want to integrate that way, you would have to write that.
Yeah. This is the internals of the App Store now. Most of the folks that actually deploy applications on top of it, they shouldn't ever see that. Unless like they have some problem and someone forum say, try adding that extra dependency there, or even better, fix your class loader to properly load classes, not just use some thread context class loader. And there are things like that. You can say, okay, given the module, this module and import services. These are the meta services, so the service loader can load the stuff. Or you can say, in this case, this one is also interesting. A Hibernate itself has an optional dependencies, you can see here, to InfiniSpan module, the org Hibernate InfiniSpan. Which means that basically, if you enable the second level cache to use InfiniSpan, in this case, it is required, otherwise it's not, so it can be optional. And when you're building the server, you can say, no, the optional stuff, don't import it to me. If no other dependency is actually using it, don't import it. So, less jars in the end built and so on. Okay, to go again, why I actually showed this slide in the first place is the thing here. The new stuff that we did in 9 is that you can define resources here as artifact and put a Maven coordinate there. The original version that still works is you have here resource, file, and name of the file in the same folder. This is really important when it comes to provisioning because all these feature packs I talked about, if we would have all the jars in it, there would be like in Maven Central that we uploaded hundreds and hundreds of megabytes of stuff that why would we have it there if it's not needed until you actually provision the server, which is the next step of the build that we do, which is basically take the feature packs and make the distribution out of it, something that you can actually run. The feature pack itself is zipped then and a zip artifact that is then uploaded or installed to your Maven local or uploaded to Maven Central. This is what we do. And allows you to create something called thin and inflated or fat distribution. That means that thin one is when the modules are like you saw it, you delegate it to Maven to resolve it, and JBoss modules itself can load it from Maven repository, even download it from remote repositories. So the whole distro is like 5 megabytes big. Only one jar is there, which is JBoss module jar, which does everything else. Or you can have the inflated one, or fat one, that has all the jars resolved. It's 100 and something megabytes for the full distribution. And it's really up to you what you need. You can build like 10 feature pixels at once. You can say, I have an example here. You can say, okay, this is my provisioning configuration. I want this is the full WildFly feature pack. And on top of that, give me also the Hibernate search feature pack. This is something so that we don't need to have Hibernate Search, for instance, part of the WildFly feature pack itself, but can be added as an add-on. Now that we have it like in current code base, all the dependencies of Hibernate Search and mods and everything are part of WildFly code base. In this change, what you can do is we ask the Hibernate Search guys provide us a feature pack, tell us which version we will consume, and we'll include it at the build, at the very last step of our build, not sooner, because we don't need it sooner. It's also done as a Maven plugin. Allows you, really cool thing is that you can say, give me the WildFly full feature pack, and then add filtering like say org, Apache, CXF modules and everything below it, which is the web services, just don't import it. So it's like 20 megabytes less in one line of exclusion and so on. You can exclude whatever you want from any feature pack you have. And the plan for this is what we are, actually the idea why we are doing this is that you will be able to download like the small WildFly core or something like that, and you'll have the CLI tool say, install me support for JSF, servlet, and clustering, and it will just grab the stuff from the internet and install it for you. Now you can do that, exactly this as part of the Maven build for yourself, but not to customize the current installation. So, step by step, this is the future we're looking at. And again, Maven plugin is really complicated. It has one line of configuration, how you can do stuff. And basically, what we plan to do for the future is, as I said, have like some CLI GUI tool maybe to install the stuff, or even in admin console to add new features. Have option to customize existing when you say you download the full version or the full WildFly, you want to just remove stuff that you don't need or add extra stuff. And split WildFly itself to many, many more feature packs so that when you're building your own distribution, you can just say, I want just this part, nothing else. Just bring me the transitive dependencies, you know what it is, I don't care, and it will bring it to you. The Hibernate Search is the first one, and we're the first one that are going that path. And we're thinking about clustering, that won't be part of main WildFly code base itself, because it's an add-on, no matter how you look at it.
So another huge benefit is that you might decide, I want that version of Hibernate Search, and I don't know, that version of Infinispan, and they don't have relation with each other.
Yeah.
So my application has those two specific versions, and can be the WildFly that is
exactly
with both of them.
Like you will say, take WildFly 9, which will be released this week, probably, the final version, and it comes with Hibernate Search, I don't know, 5, what is the version? 5.2? 5.3. And let's say in half a year or a year, you want to say, yeah, I don't want to upgrade the WildFly itself, but I want a newer version of Hibernate Search because it fixes something I really need. And this will allow you, you'll just install the new feature pack with the version 6 of Hibernate Search or whatever it will be at that day, and you'll just restart the server and you'll have the new Hibernate Search, unless you ask specifically want the old one. These are all the possibilities that we are looking into and so on. And the cool stuff with whole provisioning that we are doing here, the team build, is that team build can still work and still boot, has no problems, and it's really ideal for testing. You have like a Herculean test, and you need to have a customized version of WildFly you test on. You just say, okay, provision me WildFly servlet with these 2 extra jars or whatever you want on top of it, and provision it in the target floor as part of the build and run test against it. I can really show you, for example, we do exactly that for testing the Herculean itself. Our integration with Herculean, that is. Just a second. Do we see this? It's a bit well, that is not enough. Basically, we'll see that's the point. Well, where is the mouse? Not here. It's escaping. whole, anyone uses Herculean before I start with Herculean? Okay, but just at least. Herculean is a tool that allows you to write your code and test your integration logic that actually tests in the container itself. Can it be like WildFly or WebSphere or whatever is your chosen deployment? Not just the unit test, you can just write the code and you programmatically describe what the deployment looks like. It's a var and add these two jars in it and this AGV. And then from there on, just your tests. What it does is deploy it on a server, on a running server, or start the server, depends how you configure it, and test the code. The code that I'm showing you here, this is called WildFly Herculean, which is the code that makes sure that Herculean knows how to work with WildFly. That's basically it. And as part of this code, we, in test itself, provision the WildFly. We look here, how the dependencies, blah, blah, blah. And we just say, okay, provision the WildFly, put it to the folder WildFly servlet. The name should be the WildFly servlet. And then we say the surefire for the Herculean, just tell him, use JavaScript, the WildFly servlet. And it will use the WildFly servlet, the whole distribution that we just provisioned out of thin air, basically, to test the server, the integration if it works properly. And in this case, it uses the team provisioning. So it means that the whole folder is like 3 megabytes big. Because we're using here copy model artifacts is called. Oh, I forgot to show a bit more here. The important part here are actually these two lines. Copy model artifacts, true, false. Should we have jars there or not? Basically, if you are deploying to some server somewhere that have access to the internet, yeah, you want to have the artifacts in it so there are no external dependencies to start the server. But if you're developing the stuff all the time at your place, why move hundreds of megabytes of jars around if you just can load it from your Maven local repository that's always full already? And the other thing here is extract schemas, which is a documentation feature. So you can just look in every jar that is there when it's building the stuff. It looks for schema folder and it finds any XCD or DTD files, it copies them to the distribution itself. So you can just have documentation as part of your jars instead of having them in a separate folder, separately versioned and so on. We actually did that for the subsystem itself, so the subsystems are self-documenting and schemas for every subsystem version are part of the subsystem itself. If you look at the source code, you can see the like Untitled subsystem would have all the version of Untitled subsystem schema there, and so on and so on.
Excuse me.
Sure.
Is this provisioning mechanism also available on Jaguar CDP?
No. That's the question I was actually expecting. What we're looking here is WildFly 9, not 8, but 9. The 9 is going to be released any day now. Basically, it should be, but the project lead was on some meetings around the world, basically. But yeah, it should be released today or tomorrow. We're already working on WildFly 10, which will also get the stuff that I'm talking about here in the future. As much as we can. This is really what wish list, what we want to do. If we manage, that's a different story. There are so many battlefields everywhere. And as everyone knows, WildFly, some future version of WildFly will be part of EAP7. We are near that. I cannot talk about any exact dates or versions, but let's say yes, the next version of EAP will have this. Plain and simple. But for more, I can put into contact with our project manager guys. That's the official statement, right?
Well, close to that.
Yeah, so basically. Yeah, the plan for the future version, but it will be AP7, not with the 6, basically.
So if you have a use case here, come talk to us, because we can then, because I imagine you want probably more than what the product manager would
that was what I had planned today. These are the resources where you can just see all I talked about. WildFly core and WildFly are the separate code repositories. The WildFly servlet is actually part of the WildFly code repository. And the build tools are also a special repository where you can get the Maven plugins, the standalone provisioning that they actually use with code. It's an API, how you can provision stuff. And of course, our website, WildFly.org, which has all the latest news and downloads if you want. So, thank you. And all the questions, just keep on coming. Or I confuse you too much.
I have a question.
Sure.
If I understand well, we have two ways to build WildFly server. One is starting from core and adding the modules we want, and starting from the full feature.
And trim it down.
Down.
Yeah, exactly. Or you
We have two ways of doing the same thing finally.
It's not actually the same thing. Okay, fair. The thing is quite simple actually. You can start with core, or you can start with servlet or full. That's your thing. Where to start? The thing is that why the exclusions are good is you want just to exclude one thing, one subsystem, or include just one subsystem or two, not the whole shebang that's there. Probably that won't be very useful once we actually put more granularity into feature packs. Now we have like core and servlet and full. We should have like, as I said here, infinite span, hibernate search with feature pack, kick lock with feature pack. Pretty much every subsystem should be a feature pack.
Or you should have like a web window where you can check, yes, I want that, one download.
That thing, tools. The thing is, you have to start somewhere.
Yeah.
The thing is that now WildFly we moved to really rapid schedule, like every 6 months, 6 to 9 months release. We had 8.2 out in November. It's June. The 9 is out. Pretty much. The 10 will be out in September, October. So you have to just choose your battles carefully. So you have something at least complete that it works. That's basically it. Yeah, but on the end, at least I envision it like this, that we have every subsystem will be a feature pack. And when you will be adding the stuff, you will say, I want undertow for the web, the servlets and everything, it will say servlets. And as a result, it will bring all the transitive dependencies. That means it will bring the IO subsystem because it needs it. It will bring in everything that it needs. There are lots of subsystems that undertow itself needs for the servlet integration and so on. But yeah, currently it's like one fat feature pack. So. But it's a good start, I think.
Yeah, but even though the full one is pretty fast.
Yeah, it is definitely.
Imagine you deploy it for some reason the IoT is on the range. So let's say a smaller device.
I understand the use case. It's very nice to have just 30 data.
Yeah, the thing is that some people really use just few features, and the whole server is too big. There are also some crazy ideas about for IoT deployment, and microservices called WildFly Swarm. You've heard about that maybe. This is a fairly new project. The Alpha 2 was released last week. It actually does it a little other way around. You actually have a code where you describe your application. Like I need a JAX-RS application, and you say add REST mapping, add REST handler, and things like that. And when you do that, when you build it, behind the scenes, it builds custom distribution of WildFly in one fat jar. So you get, which you run just like Java -jar, and name of that jar that you build it, and it starts the WildFly with just the features that you used in your code. This is experimental project, but this tooling that we have here enables all that. So you have one jar for everything. So there is a lot more to come, but in general these are boring stuff, building and provisioning. Most people don't really care about this. But we are kind of happy because we are now moving the code around a lot, and lots of features that are not part of the main code repository of WildFly can now move out again, just because we can include them just with the feature packs at the distribution time. For instance, the high message is a really good example. We have zero codes in WildFly that will do anything, but in the build itself, we have a bunch of like 20 components that it needs, the jars and dependencies. We need to bring into our build, our XML is bigger, we have to manage all the versions for the component that's not even ours. And then the guys in the upstream do something, they change something, how the dependencies are done, and that's not reflected in our code base. There are problems and people are complaining the stuff doesn't work. So they just say, okay guys, just get us the version that works with us and we won't care anymore. So we can really work just on the core stuff that application server should be doing, not some utility components that people like, which are useful, but not really necessary for main server to run. Any other questions at all? We can talk about even Java itself.
Yeah, it seems relatively easy to create a new feature pack.
Yeah.
And then I'm just wondering if I was to do my own feature pack, what kind of validation you have to do? I mean, what kind of at the same time, it seems that it's relatively expensive for you to build all the. Otherwise, it would already be there in the new version. So I imagine that there are some.
It's not expensive to do it, just tedious work and no one wants to do it. Basically, that's the main reason. And we were rushing a bunch of features that we needed to do, and there were like two guys on their spare time doing this. That's the main reason why it's already done. But the validation itself, you can just I can show you the code. It's not really.
When you look at the code, what's difficult is more the actual modularization of what you're doing, because all of a sudden you've got a class loader issue because you were just expecting a flat class loader looking at some resources. No longer there. Why? And you have to maybe update the library so that it doesn't use the thread local class loader, but the actually provided one from the module and so on. That is what has been taking us most of the time when we modularize high-level search or VM or and so on. Looks like Office.
Yeah, really. What is this resolution? It's crazy low.
Just double click on it.
I need to actually the folder structure is what I want to show. That's the thing. No, I don't want to import. Basically, this is the feature pack, the main core feature pack. Let's take this. This is the code base of the WildFly. It's not really servlet feature pack. This is the smaller one. That's why I'm showing this one. As I told you, we have a feature pack here. The XML itself, I won't open it because it's stupid. It just extends core. And this is what we have. Source main. Basically, everything is a resource because we don't have any code there. Because you don't need it. And we have here configuration, standalone, the template. This is the template. And I don't know, okay, I'll try to show both. You just specify which are the subsystems that are really present. This is the, when we talked earlier, what is the subsystem in the servlet one. The login, of course, deployment scanner, the E, because it provides that smooth stuff. Request controller, naming, security manager, and underdog. That's pretty much all it does. And the template itself provides everything else. You know, the standalone XML, we use some templating to build it together. That's basically it. We just drop here the extensions that are defined there. All the other stuff is, you know, the standard socket magazine, things like that. And where these folders are already defined in the feature pack configuration. You say, use this template in this file. It could be whatever folder you want. We just use something that's familiar. It is pretty much similar for the main node. The main has just a template that's a little different. It's for the main node. had the deployment folder empty with the README to tell people how to use the deployment folder, and some default management users and things like that. Basically, just part of the end distribution, just replicate the folder structure here. The welcome content, just when you open the port, local port 8080, you say, welcome to WildFly, nothing else. And the biggest thing, of course, modules. These are the whole modules. See, everything is really well, how to say it properly, granular to the pretty much small level. We have like servlet, WebSocket module, GSP module, and so on. And we also have here the JavaX modules, like the servlet API, the JSP, the JCTL, transaction, WebSocket, and so on.
Oh, this is in the servlet feature pack?
Yeah, this is all servlet feature pack. What we're looking here. This is all what gets added on top of core. What?
It has quite a lot of Java EE.
Yeah, it has servlet is Java EE.
No, but I thought it was just a strip down on your so-far.
Yeah, we don't strip down the full. We build from the zero, basically. We just add all the extra Java EE stuff that just the kernel for servlet. The thing is that for the servlet, but where the stuff gets complicated and why it's not really done. To be fair, I'm not sure that validation should really be in the servlet feature pack. It should be in the full one. Even if it's there, it's nothing wrong if it's not enabled by bin validation subsystem and so on. So, you know, you try to do it the best effort, and then it's a lot of work.
See, because this one does Jack Cerar, so
No, it doesn't. It could be maybe dependency of the servlet itself. I'm not really sure.
Or you can, no, but you can inject a validator in it, but so can you an EJP, so that's not really.
Yeah, here we don't have AGPs.
No, right.
So, this is the problem. Maybe there's some stuff that you try to make it work, you know, and things people just. The thing is, the invalidation point of view, if I would now remove this module and try to build it, it will complain that probably this module is missing that module it is referencing. I will easily see which one is actually using it. But just for example, this is how the stuff is done. It's some work. In our case, it's not that big of a problem because we already have everything modular. We just have to move it all around and make sure that the proper feature pack is really the owner of the module, which is the biggest problem. Who is the owner and why? And who needs to depend on him? And what is the shared set of the common model that everyone has? And this is where it gets complicated, not the building of the models itself. That's basically it. JavaX, and we have, for example, WildFly extension undertow, which is the entry point for the subsystem. This is the subsystem itself. Basically just say artifact is WildFly undertow and has all these dependencies and so on. And here you also see, you know, clustering is optional. You know, if you add it and install it later on, it will use it, but if not, well, no problem with that. And so on and so on. The undertow subsystem is quite a big beast and quite complex. I think just one more thing I can show you and then we're done. We're out of time. It's really awesome, that huge resolution. Where we are here. This is the code of the subsystem itself. I want to show you this. In the subsystem itself, we have things like subsystem. There is some convention how you do it. In the resource, we have subsystem templates. In this case, we have undertow subsystem template. And when you saw in the feature pack, we said these are the subsystems we want to have, but no one saw what is the configuration of that subsystem. And this is defined here. This is the default, basically default template for the shipping configuration of the subsystem. If anyone that uses WildFly before saw this default configuration, default listener for default host, and the configuration is there. So we do a lot of this stuff by convention when it comes to the feature pack and subsystems. And again, lost my mouse. And the last thing is this schema. When I told you that we do extraction of schema if you want, this is the documentation of the subsystem XML. So that's pretty much it. Find me on the hallways anywhere, just grab me and ask anything else. Thank you.
Thank you.